Okay, so two kittens are on a roof of a house. Which one falls off first? The one with the smallest mu. Okay, so let's go back to review friction. Remember that friction, the force of friction, is proportional to the normal force. It's proportional to how hard two things are pressed together. How hard it is to slide them relative to each other is dependent on how hard they're pressed together. So if we talk about trying to slide, this typical just trying to slide a box against the floor, if we push on it and we push on it and we push on it and it's not moving, the static frictional force is equal to the is equal to the pushing force. But at some point we push hard enough so that that box begins to move, or so that right at the point just before the box begins to move, right? So here the thin box is not moving at all, a equals 0, not going anywhere. But at the point that we're pushing hard enough, just hard enough to get the box just to move, or just before it moves, right? It's a fine line. We just got to say we've got sort of the F of S max. If we push any harder, it means it starts moving. Once it starts moving, this is what's important, is that the maximum static frictional force is the force that's keeping it from moving just before it starts moving. But as soon as it starts moving, let's erase the kittens on the house. As soon as it starts moving, right, the friction turns into kinetic friction. So we can be pushing with the same force, right? So let's say that we started, we're pushing like we started and we were pushing with a force of 5 newtons. I don't have a laser pointer here. And then we're pushing harder and harder and harder, and we get up to 20 newtons, above 20 newtons, at 20.00001 newtons, it starts moving. So that's the push here. And so once it actually starts moving, so this is just before it starts moving, or right when it starts moving. Once it starts moving, right? It's moving in that direction. It must speed up. Then the frictional force gets smaller, right? The frictional force gets smaller, and it turns into a kinetic frictional force. Why does it get smaller? Well, in practice, not in practice. I mean, in physically, why it gets smaller is you can look at the little picture of me in the lower left-hand corner. Remember the fingers that are interlocked. When it starts moving, it starts sliding, and so what we've done is we've smoothed that surface over a little bit. We've broken off some of those little pieces, and that's why we leave that wonderful word detritus behind, because we actually had to have broken off some pieces, and so it makes it easier to move. And so the kinetic frictional force, that's from a microscopic point of view, but from a macroscopic point of view, from the point of view of you just watching a box sliding across the floor, just think about doing it yourself. Push a file cabinet. It's really hard to get that file cabinet started moving, but once you got it moving, it's easier to move. Right? Think about just pushing something heavy. It's easier to move it once you get it started. We're pushing a car on the road. Though in that case the wheels are rolling, there's still static friction that keeps you from getting it moving. Once it starts moving, it's kinetic friction. It's just kinetic friction in the bearings that is allowing you that is resisting your motion, and it's easier to keep it moving than it is to get it moving. So the frictional force gets smaller once you start it moving. Frictional force gets smaller than the maximum static frictional force. And that means that mu sub k is always less than mu sub s. Okay, so what are these mu sub k and mu sub s? Remember, mu sub k and mu sub s are constants that have to do with the physical properties of the surfaces in contact. So by surfaces in contact, we mean right here, right, where the surfaces that are in contact. And how do we know what it is? How we know what it is? Well, we could calculate the coefficient of friction by knowing what our pushing force is, and by measuring the frictional force or something. We could calculate them, but typically the coefficient of friction might be something that we look up. So, for example, if we want to know how hard it is to push a cardboard box on a wooden floor, we could look up the coefficient of friction between cardboard and wood. It's going to be about 0.5. If we want to know how hard it is to slide a piece of rubber on an asphalt road, we could go look it up, rubber on asphalt, and we'd find that the coefficient of friction is 0.7 or 0.8. If we want to know how hard it is to slide a piece of metal across ice, we go and look at that up, and maybe the coefficient of friction is 0.1 or 0.2. What you should notice is that these coefficients of friction, coefficient of friction are all basically between 0 and 1. Whether they're kinetic or static. I was not careful when I just gave you those numbers, whether we were talking kinetic or static. The static friction is always a little bigger than the kinetic friction. Sometimes a lot bigger, but you're always just a little bigger. So if we're talking about cardboard on wood, right, sliding a box across a wooden floor, the static frictional coefficient might be 0.5, the kinetic frictional coefficient might be 0.4. You can just look them up. So the coefficient of friction in general is between about 0 and 1. 0 would mean no friction, right? Coefficient of friction equal to 0, whether it's kinetic or static, would mean no friction, right? That means that the frictional force is 0 because mu times Fn is 0. A coefficient of friction of 1 means that, right, that would mean that the force, let's say that it's sliding friction, let's say it's kinetic friction. It doesn't really matter if it's kinetic or static, but let's say it's kinetic. It means it would be equal to Fn. So let's take, for example, the box on the floor with a weight of mg, and we're pushing on it with F push, and we ask, well, mg is down. Whoops, I just drew mg. And the normal force is up, and the frictional force opposes the push, whether it's moving or not, opposes the push. If the coefficient of friction was 1, then the frictional force that opposes your motion, whether we're talking static or kinetic, in this case I said kinetic, would be equal to Fn. In the picture that I just drew, Fn is equal to the weight. So so what would the frictional force be? The frictional force would be equal to the weight. It would be the same as I would have to push with the same force as if I was picking up the object. Typically, pushing something is going to be easier than picking up the object. Typically, not always, but pushing something is going to be easier. So that's what tells us that typically, right, if the frictional force, look at the iPad, the frictional force, if the kinetic friction is equal to Fn, in the picture that I drew, where everything's all the forces are perpendicular to each other, therefore the frictional force that I would have to use in order to push the body is equal to its weight. And that's the same as picking it up, but typically sliding something across a surface is easier than picking it up. And so that's what tells us that typically, but frictional forces are typically smaller than the weight of the body. It's easier to slide something than pick it up. That's all we're saying. So that's typically. Typically. So therefore, that tells us that mu tends to be less than 1. The fact that it's easier to slide something than pick something up tells us that mu is less than 1 typically. Typically. Again, whether it is kinetic friction or static friction, it's usually easier to get something sliding or slide it than it is to pick it up, so that means that mu is less than 1. But it doesn't mean that mu is always less than 1. Some people will define the coefficient of friction as being less than 1, but that's not true. If we glued that body to the floor, then we would have to push with a force greater than its weight. We may have to push with a force greater than its weight in order to get it moving. That meant that the static friction coefficient was greater than 1. Now, I'll tell you that the kinetic coefficient is never going to be greater than 1. The kinetic coefficient is never going to be greater than 1, but even the static coefficient is usually less than 1, unless we glue the body to the floor or something like that. So they're typically between 0 and 1, but not necessarily so. Typical. Okay. What are the units of the coefficient of friction? What are the units of coefficient of friction? Well, if by definition FF, whether it's kinetic or static, maximum static, right? FF, let's say FFK is mu K Fn, or FFS maximum is mu S Fn. And look at those two equations, and you see we have a force equals a constant times a force. So with the units, therefore, mu must have no units. Has no units. It is a unitless quantity. It's just a proportionality constant. It's a unitless quantity. Okay, so that's all we need to know about friction.